Got to talk about adding and subtracting rational expressions real quick, and then we're done with this unit. Let's start real simple. If I have 1/3 plus 3/8, those aren't really comparable. We got to find a least common denominator. You can always multiply the denominators to find a common denominator. Thirds can be subdivided into 24ths, and eighths can be subdivided into 24ths, because 3 and 8, they're both factors of 24. What I'm going at is, if I multiply this guy by 8 over 8, and I multiply this guy by 3 over 3, then I have 8 24ths on the left, and I have 9 24ths on the right. It's 3 times 3 is 9, 8 times 3 is 24. So altogether I have 17 24ths. So all four of my polynomials here happen to be degree 0, the 1, the 3, the 3, and the 8, but we can handle more complicated expressions exactly the same way. So if I asked for 4 over x plus 10 over y, what's a common denominator here? What's the least common multiple of x and y? Well, you might have to reduce later, but you can always just multiply each one by the other. So we'll multiply this by y over y and this by x over x. So our denominator on each is going to be xy when we're done. Specifically, over on the left, we have 4 times y over xy, and on the right, we have 10x over xy. I'm kind of changing the order between steps, but it's okay because multiplication is commutative. The order does not matter. The sooner you get used to that, the better off you'll be. We have 4y plus 10x over xy here. That's as far as we can go. There's no simplifying this. Some of you will be tempted to draw lines through here. Do not do that. There's no y in this term, so I can't cancel it out of the denominator. That would be a big mistake. It's one of the most common mistakes I see in this class. So don't do that. We are done. Let's do a couple more of these. If I add, say, c plus 2 over 3 minus c minus 4 over 4, follow the pattern. Multiply this guy by 4 over 4. Remember, we're going to have to distribute that 4 to the c plus 2, so I'll draw some parentheses to remind me. Same thing over here, I'll multiply by 3 over 3. Need to distribute that to the c minus 4, so I'll draw some parentheses to remind me. See, then over on the right, we're going to have 4 c's plus 4 2's, that's 8. So 4c plus 8 over 4 times 3 is 12. We're going to subtract from that 3 times c minus 4, so that's 3c minus 12, all divided by 12. See, this whole expression is getting multiplied by the 3, so I had to distribute. Now how we do this is, well, this is really just the same as 4c plus 8 minus 3c minus 12, all over 12. I can combine like terms, just like I taught you in section 1.4. 4c minus 3c is 1c. 8 minus negative 12 is 20. That's all divided by 12. There's no canceling we can do here. I know you're going to be tempted to pull a 4 out of the 12 and out of the 20, but the c ain't got a 4. Think of it this way. Can I factor a 4 out of the entire numerator to cancel with the 4 down there? And the answer is no. 4 comes out of this term, but it don't come out of that term. So there is no simplifying this. This is our final answer. Let's do one more just to show the kind of the full experience here. Let's say I had an x minus 1 over x plus 1, and I wanted to subtract from that a 2x plus 3 over 2x plus 1. This one's going to kind of be a pain. It's going to have to get a common denominator, but this time we're multiplying by binomials. Only common denominator I can think of is if we multiply x plus 1 and 2x plus 1. I'm going to draw in a lot of parentheses here to remind myself I'm going to have to distribute a lot of things. Pop a 2x plus 1 over 2x plus 1 here. Pop a x plus 1 over x plus 1 here. So I'm going to have a common denominator. My common denominator is this 2x plus 1 times x plus 1. So I'll copy that down here. I'm not real worried about trying to simplify that right now. The numerator is going to be over here, 2x plus 1 times x minus 1, minus over here, 2x plus 3 times x plus 1. Now, of course, we can simplify this. I'm going to start by foiling each of these. So those are each going to get foiled. 2x plus 1 times x plus 1. First is 2x squared. Outside is minus 2x, and inside is plus 1x. Those make a minus x. Outside and inside are always what's going to combine if you're multiplying two first-degree polynomials. Yeah. And last is plus 1 times minus 1. It's negative 1. Here, 2x times x is 2x squared. We've got a 3x and a 2x inside and outside. Those make a 5x. We got a 3 times 1 is a 3. That's our last. Like I said, I'm not too worried about... I mean, worst case scenario, if I foiled out the denominator right now, I might miss that something cancels. Now, nothing's going to cancel, but if it did, I wouldn't want to miss it. Up top, subtracting term by term. 2x minus 2x is nothing. X minus 5, negative x minus 5x, negative 6x. And negative 1 minus 3 is minus 4. Down here we got 2x plus 1 times x plus 1. If you want, we can leave this, we can leave this as the final answer. Or we could pull a minus 2 out of the numerator, since technically it comes out, and have a 3x plus 2, just to check that don't cancel with either of the factors down here. It don't, so either one of these is good as a final answer. It don't matter which one you pick. And that's all there is to rational expressions. Like I said, not going to spend too much time on those, but they are on the final, so I did want to cover them a little bit. All right. Join me next time. We'll be starting chapter 2, where we, so far, all we've done is algebra. We've been manipulating expressions and such, but we're going to get into geometry real soon here. So I'll see you in a minute.